Good morning, students. Our next concept is product of determinants. Let us take the two determinants, how to multiply them. Okay, here P, Q, R, X, Y, Z, A, B, C. This is one 3 by 3 determinant, and L, M, N, R, S, T, D, E, F. This is one more 3 by 3 two determinants. Okay, now how to multiply them? Actually, we can go how multiply the matrices, like that you can multiply that two determinants. That means first row to, that means first row in first matrix to first column in second matrix, corresponding elements PL plus QR plus RD. That gives the resulting matrix first entry, this position. Okay, first row to second column gives second entry. First row to third column gives the third entry in the first row of the resulting matrix. So you know how to multiply. Same way, second row to first column, second column, third column gives us second row entries, and third row to first column, second column, third column gives the third row entries of the resulting matrix. That is one method. We can go for that method also, but we can go one more method, that is nothing but PQR to LMN. Okay, that means first row in the first matrix to first row in the second matrix gives a A11 position, PL plus QM plus RN. This is next. First row to second row gives a second entry in the first row of the resulting matrix. That means PR, QS, RT summation. Next, first row to third row gives a first row of the third element, PD plus QE plus RF. Similarly, second row to first row in the second matrix, second row to second row, third row to third row, just multiply and add them. Next, third row to first row, third row to second row, third row to third row gives third row entries in the resulting matrix. Like that also we can multiply, but in the matrices we should go in this method only, PQR to LRD. That means first row to first column, row and column wise we should go, but in the determinants we can go through row to row. So this is the important procedure, product of determinants. Based on this one, you go for one problem. If L1 square plus M1 square plus N1 square is equal to L2 square plus M2 square plus N2 square is equal to L3 square plus M3 square plus N3 square is equal to 1, and L1 L2 plus M1 M2 plus N1 N2 is equal to L2 L3 plus M2 M3 plus N3 N2 N3 is equal to L1 L3 plus M1 M3 plus N1 N2 is equal to 0. Then find the determinant of L1 M1 N1, L2 M2 N2, L3 M3 N3. Okay, see directly if you go this determinant, we cannot get these terms in the determinant. What we have to do, nothing is there to do. So that's why for this one, if you take the square of this determinant, if you take and simplify, for suppose the square of this one is equal to, if you get 2, then only this, okay, square of this one is equal to, if you get 4, then only this determinant is equal to what you get, plus or minus 2. Like that you can take the answer. Okay, see, once you check here, so take a square of this determinant, L1 M1 N1, L2 M2 N2, L3 M3 N3 whole square you take. So just you write as L1 M1 N1, L2 M2 N2, L3 M3 N3, and write L1 M1 N1, L2 M2 N2, L3 M3 N3. Directly you take, just you multiply. Once you multiply, L1 into L1, L1 square, M1 into M1, M1 square, N1 into N1, N1 square. That is the first entry of the first row. Okay, so L1 square plus M1 square plus N1 square, what they given? 1. Next, in the second entry in the first row, how you get L1 M1 N1 multiply to L2 M2 N2, that gives L1 L2 M1 N2 plus N1 N2. What is that value? Becomes to 0. Next, first row to third row, L1 L3 plus M1 M3 plus N1 N3, L1 L3 plus M1 M3 plus N1 N3, okay, is equal to also 0. So that means what you get, directly I can write 1 0 0. So after multiplication, what resulting values I have written here. Similarly, so second row to first row, L1 L2 plus M1 M2 plus N2 N1, that means L1 L2 plus M1 M2 plus N1 N2, that value also becomes to 0. Next, second row to second row, L2 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 square, M2 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 square, N2 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 square, L2 square plus M2 square plus N2 square also equal to 1. So that is the entry here. So second row to third row, L2 L3 plus M2 M3 plus N2 N3, that is also 0. Similarly, third row to first row, L3 L1 M3 M1 N3 N1, that is also 0. Next, L3 L2 M3 M2 M3 N2, that is also 0 summation. Next, L3 square M3 square plus N3 square, that is also 1. So this determinant expand it. It is nothing but identity matrix. It is nothing but identity matrix. So determinant of identity matrix is always 1. Square of this one is equal to 1 means only L1 M1 N1 L2 M2 N2 L2 M3 M3 is equal to plus or minus 1 you get. Okay, this is equal to 1. So directly I didn't write here. So directly only if you want this one, that is nothing but plus or minus 1. You can understand. Okay. So here next problem is, if alpha comma beta are the roots of x square plus x minus 1 is equal to 0 and Sn is equal to alpha power n plus beta power n, then 3 1 plus s1 1 plus s2 1 plus s1 1 plus s2 1 plus s3 1 plus s2 1 plus s3 1 plus s4 value is equal to, he is asking. See here this determinant 3 I can write as 1 plus 1 plus 1, just to understand. 1 plus s1 means 1 plus alpha plus beta. S1 Sn is equal to alpha power n plus beta power n. So S1 is equal to alpha power 1 plus beta power 1. Yeah, S2 is equal to alpha square plus beta square. S3 is equal to alpha cube plus beta cube. S4 is equal to alpha power 4 plus beta power 4. Just to substitute them. 1 plus S2 means 1 plus alpha square plus beta square. Same. 1 plus S1 means 1 plus alpha plus beta. 1 plus S2 means 1 plus alpha square plus beta square. 1 plus S3 means 1 plus alpha cube plus beta cube. 1 plus S2 means 1 plus alpha square plus beta square. 1 plus S3 means 1 plus alpha cube plus beta cube. 1 plus S4 means 1 plus alpha power 4 plus beta power 4. See here, it is the one determinant. If I split into product of two determinants, this one, then our problem will be very easy. And mostly like these problems, you should understand both determinants should be same. If you want to split into two different determinants in multiplication, if you take those two determinants also identical, that means corresponding entries all in all rows or all columns, all entries are equal, then you can write directly whole square. Det A into det A you can write as det A whole square you can write, then you can simplify easily. So that is the way to do this problem. See here how to write two determinants, those products should be equal to this determinant. See here, this is 1 1 1 1 alpha plus beta, 1 alpha square plus beta square. See here if I write 1 1 1 here, 1 1 1 here in the second determinant, 1 into 1 1 1 into 1 1 1 into 1 1. So 1 plus 1 plus 1. Next 1 into 1 1 1 into alpha alpha, 1 into beta beta, 1 plus alpha plus beta. Okay. Next, so 1 into 1 1 1 into alpha square 1 into beta square. See, it is satisfied. Okay. Similarly, also check it out, second row to first column, sorry, first row, 1 into 1 1 alpha into 1 alpha beta into 1 beta, 1 into 1 1 into 1 1 alpha into alpha alpha square, alpha beta into beta beta square. So it was adjusted if you write like this. So 1 1 1 1 alpha beta 1 alpha square beta square, 1 1 1 1 alpha beta 1 alpha square beta square. Just how, sir, how I get an idea means, first of all, here 1 1 1 is there, 1 alpha beta is there, 1 alpha square beta square is there. First you write like that. If you are comfortably adjust the entries, then you go directly. Otherwise, once you just interchange framing the entries, okay, by doing more problems we can understand how to write. Okay, see here both are equal. So this product becomes to 1 1 1 1 alpha beta 1 alpha square beta square whole square. Now expand this one. Actually, you know this one already, I gave some standard results 1 1 1 1 alpha beta, 1 alpha square, beta square. If you expand this one becomes to 1 minus alpha, alpha minus beta, beta minus 1 whole square. Otherwise, once you expand it, make these two entries are zeros. Or these two entries are zeros by using column operation or row operation, you get this product. Okay, this one whole square you have. So once you multiply, here this is nothing but 1 minus alpha into alpha minus beta. That means one first you take these two, 1 minus alpha into beta minus 1. What you have that for that one product of this product whole square you write here. So 1 into beta, beta minus alpha beta. Okay, and here what you have 1 into 1, 1 and minus alpha into 1 minus alpha, like that. Okay. Students, here small correction, actually 1 into beta, beta, 1 into minus 1, minus 1, minus alpha into beta, minus alpha beta, there is no 2, and minus alpha into minus 1 plus alpha. Take this product as whole square. This is beta minus 1 minus alpha beta plus alpha whole square, and alpha minus beta whole square take separately. So here why we have to take separately means we get here alpha square plus beta square and alpha beta. Okay, see here this one, if you expand this one, you have beta plus alpha and alpha beta. Here also only alpha beta. Okay, see here given condition, here also one small correction, you take here plus 2x. Okay, x square plus 2x minus 1 is equal to 0. So actually if alpha comma beta are the roots of this one, then alpha plus beta is equal to how much? Minus b by a. Minus b by a means minus 2 by 1, that is minus 2. Alpha beta is equal to how much? C by a. C means here minus 1. Minus 1 by 1 means minus 1. So write all these terms in terms of alpha plus beta and alpha beta only. So this one you can write as alpha plus beta minus alpha beta minus 1 whole square. This alpha minus b, a minus b whole square formula, a plus b whole square minus 4ab. That means alpha plus beta whole square minus 4 alpha beta. So this alpha plus beta you can write as minus 1, and minus of this alpha beta you can write as minus 2. So that means actually it's small mistake. So this one you can write as 2 into minus 1 is nothing but minus 2, you can understand. So this minus is minus 2 into minus 1 minus 2. This is minus 1 whole square into my alpha plus beta whole square means say minus 1 whole square minus 4 into alpha beta means minus 1. So this is nothing but minus 1 minus 2 minus into minus plus 2. So minus 2 plus 2 whole square, 0 square, 0 square, 0 into anything is 0. So this answer for this question is 0. So here already we completed trigonometry. So find determinant of cos of a minus p, cos of a minus q, cos of a minus r, cos of b minus p, cos of b minus q, cos of b minus r, cos of c minus p, cos of c minus q, cos of c minus r is equal to. See here, this one how to write means first we have to take as two different determinants. So already we have the formula cos of a minus b. Cos of a minus b formula cos a cos b plus sin a sin b. Okay, this expression becomes to cos a cos b plus sin a sin b. This is nothing but cos a cos b plus sin a sin b. This is cos a cos q plus sin a sin q, cos a cos r plus sin a sin r. Actually in product you have only two terms, cos a cos b plus sin a sin b. So without correcting on this paper, just I am doing in some other paper. See here, cos of a minus b. Okay, this one you can write as cos a cos b plus sin a sin b. See here to express into two different determinants in 3 by 3 order, we need one more term. Actually you have like this, if you multiply, this is one determinant, this is one determinant. See here, if you multiply these entries, so this one to this one, this one to this one, this one to this one, if you multiply, you have three terms, but here two terms are there. Then third term becomes to take as 0. Okay, just you understand here that determinant how I am writing is for in the this in cos A cos B sin A sin B, and this one you can write as 0 into 0. So just I am writing this cos A with sin A and 0 as one row. In the second determinant, first row as cos B and sin P and cos P sin P and one more 0. Just I am writing like that. So this is nothing but cos A sin A 0, cos P sin P 0. Same here, cos B sin P plus cos P plus sin B sin P. So cos B I have written here in the second term, sin B I have written here. Okay, and 0 I have written here. Similarly with P, cos P I have written, cos P is same, this one, this multiplication gives okay, cos P I have written here, cos sin P I have written here, and 0 I have written here. Similarly same, just you understand how to write cos A sin A 0, cos P sin B 0. For this one, cos B sin B 0 you write here, and cos Q sin Q 0 you write here. Next, cos C sin C 0 you write here, cos R sin R 0 you write here. Once you multiply, what you have? Cos A cos P plus sin A sin P, 0 into 0 0. That means what you have? Cos of A minus P. Next, cos A cos Q sin A sin Q, 0 into 0. Cos of A minus Q. Cos A cos R sin A sin R, 0. Cos of A minus R. Formulas. You are getting every term. Similarly, second row and third row, once you check it out, you get the answers. Just once if you write for one entry, then you may get all entries similarly. Okay. So this becomes to in any row or column, all entries are zeros, then the determinant is equal to 0. So this determinant 0, this determinant 0. So 0 into 0, that becomes to 0. Next one. Find determinant of 1 cos of alpha minus beta cos of alpha minus r, cos of beta minus alpha 1 cos of beta minus r, cos of r minus alpha, cos of r minus beta, and 1. This is 1 here. So this statement. So same way we have to split it. See here, you are getting cos alpha cos beta plus sin alpha sin beta. Okay, it is cos alpha cos gamma plus sin alpha sin gamma. Here I can write as this 1. How can you write this one? Once you check it out. Okay, see here I just write as product of two determinants, this one. Okay, the product becomes to this determinant. Okay, if I write like this, cos alpha sin alpha 0, cos alpha sin alpha 0, what you get? Cos alpha into cos alpha cos square alpha, sin alpha into sin alpha sin square alpha. Because of I have to get 1 means in terms of trigonometry, 1 when you get cos square alpha plus sin square alpha in terms of cos and sin function. So that's why this one I have written as cos square alpha plus sin square alpha plus 0. Because of 1 cos alpha I have written here. Because of, if you write like this 1, if I write like this, cos square alpha plus sin square alpha plus 0, because I should get 3 terms. So cos alpha plus sin alpha plus 0 into 0. This cos alpha sin alpha 0 I have written in the first row of first determinant, and the second cos alpha sin alpha 0 I have written here.